Hi, a warm welcome to you. Welcome back. So in the last video we have seen some problems on intersecting lines and the relation between the angles, and we tried to resolve some problems. In this video and mostly the next video we'll be focusing upon the parallel lines and the angles, the relationships whatever we have established. We will try to leverage them and try to solve the problems. So what will be the conditions we'll be using are: 1. Opposite vertical angles are equal. 2. That is for the condition when the two lines are intersecting with each other, and if two lines are parallel and they are intersected by transversal, we'll be using that corresponding angles will be equal, alternate pair of interior angles will be equal, corresponding angles will be equal, and also interior angles on the same side will be supplementary. Okay, so let's look at these three problems. First we look at the first problem, in which we have two lines L and M which are parallel to each other, and they are intersected by two transversals, that is P and Q respectively. Now we have been given this figure and asked to find out the angles at whatever the angles, and also find out the values of x comma y comma z. So let's start. So the approach whenever you have these type of problems, like when you have parallel lines and transversal, should be always to get it to a particular point. That means whatever the other information you have, try to get it to one particular point by using the relationships whatever we have. Now suppose here you can see that now my objective is to get all these information at A. So I have to see what relationships I can use. Now if I see here at B, the angle is x. You can see that the angle is x. This angle, whatever I have QBL, I am just taking it, and this PAB, they are corresponding to each other, right? So this will automatically will become how much? This will become x. This will be x, right? Similarly, if you see here y by 2, y by 2, this angle is corresponding angle of this, but this angle is also corresponding angle of this. So this becomes y by 2. Similarly, you can see here this angle, whatever I am actually showing here, this angle at A, near to the letter A, and at the letter C, these two angles also corresponding to each other. So this will become 3z. Once you get that, it becomes pretty simple, right? Now we can leverage whatever the relations we can use, and we can find out the values of x and y and z. First let me use the supplementary on this too. So this angle here should be, sum should be 180 degrees on the top, on the L side, right? So I am saying 3x plus x is equal to 180 degrees. That gives me 4x equal to 180 degrees, which gives me that x equal to 180 by 4, nothing but equal to 45 degrees. So I know x equal to 45 degrees. Now once I know this, remaining becomes pretty simple, because if I know x, I can equate it with this by opposite vertical angles. Similarly, I can equate with y as the vertically opposite angles, and I can find out the values of y and z. So let's go ahead and do that. So we will take these vertically opposite angles. If you take them, x equal to 3z, I want to find out z. So I will say 3z equal to x, which implies that z equal to x by 3. That's nothing but equal to 45 degrees by 3. That's nothing but equal to 15 degrees. So my z is equal to 15 degrees. Okay. Similarly, you can have a look here. These two angles are vertically opposite angles. Which angle? 3x and y by 2 are vertically opposite angles. So I will say y by 2 is equal to 3x, which implies that y equal to 6x, nothing but equal to 6 into 45 degrees, that's nothing but equivalent to 270 degrees. So I got the values of x, y, z. What we have done? We have transposed. We have actually moved from here to this particular point so that I can establish relationship here, because I can leverage the straight line relationship and also I can leverage opposite vertical angles relationships. So we are able to find out x, y, z. Now let us find out what are these angles. You know the x is 45, so 3x becomes 135. Now I know this as 135, this automatically will become 135. Similarly, I know if this is 135, this is nothing but 45, because both of them should be 180 degrees. Similarly, this also will become 45 degrees. Now you want to cross check. See, z equal to 15. 3 15s are 45 degrees. So this is fine. Similarly, y by 2 equal to 135 degrees. Y equal to 270 degrees. That's what we have got. So for this type of problems, the summary is your approach should be always to get all the values at one particular point, whatever the point you want, either from here or here, anywhere. At one point, if you are able to get them, then it becomes very easy. Even you have forgotten about alternate interior angle, just remember that you are able to find out the alternate pair of interior angles relationship by using the corresponding angles and opposite vertical angles. So anytime you can go back to the corresponding angles and opposite vertical angles and can resolve the problem. Okay, let's move forward. Go to the second sum. In the second sum, we have two lines, AB and CD. Okay, AB and CD. There are two lines, and they have been intersected by a transversal L. We have been given some information. We were asked to find out the values of x and y, and we also have to show AB is parallel to CD. So we don't know that AB is parallel to CD, but we have to establish. Now how I will prove that two lines are parallel to each other? Let's just step back. We have seen in the last video that if I have two parallel lines intersected by a transversal, the corresponding angles are equal, or alternate interior angles are equal, like this and this, or x and y. But now we want to take exactly the converse of that. Now we want to establish that either the corresponding angles are equal or alternate angles are equal, so that we can say that these two lines are parallel to each other. Let me just repeat it again. In the last video, we just took the converse of this, where we have two parallel lines intersected by the transversal. We have proven that the corresponding angles are equal there. Now we want to leverage that, and we want to say that the converse of it as, if two lines are intersected by a transversal and the corresponding angles are equal, then those two lines are parallel to each other. I think that should be pretty clear to you now. Okay, let's go ahead. Let's look here where we have the information. I can take A, or I can take this particular point. Let me start here. What you can see here, these two angles are vertically opposite angles. So I know y equal to 130 degrees straightforward. I don't need to do anything. Similarly, if I go here, I have x and I have 50. So what I can establish with that? Without any doubt, I can say that this is a straight line. So these two angles are supplementary. So I can say that x plus 50 degrees is equal to 180 degrees, which gives me x equal to 130 degrees. Now see here, this angle is 130 degrees, this angle is 130 degrees, this angle is 130 degrees, and also this particular angle is also this angle is also 130 degrees. Now what you can see from here is the corresponding angles are equal, the alternate angles are equal. That means we are able to establish that AB is parallel to CD, because the corresponding angles, what are those corresponding angles? I can take any angle. I can say this angle and this angle are equal. Now what's the meaning of that? If this particular angle is equal, automatically remaining all angles will set in, right? So that's why we are proving that these angles are equal to each other. So we are saying that because the corresponding angles are equal. Pardon me for that. I think you can understand that corresponding angles are equal. So this is very interesting. Just remember that whenever you have two lines and you have to prove that they are parallel to each other, your focus should be to prove that corresponding angles are equal or alternate pair of interior angles are equal. Okay, let's move ahead. Move ahead to the last one. If you remember in the last video, just before we closing the video, I said that let's try to prove that the sum of angles of a triangle is 180 degrees. I think you are able to crack it. If you are unable to, that's okay, fine. We will see it in the next video how to solve it. That's pretty simple. Now for now, let's say that sum of the angles of 180 degrees. You don't know how it is, that's okay, fine. Let's take it as granted 180 degrees. Now see here, there are two triangles and the sum of all those angles should be 180 degrees. Now what is the information we have been asked here? We have been asked to find out the value of x. I have to find out the value of x. Now I know that in this triangle, what is this triangle? ABO. I know that this angle I don't know. This angle I have to find out. This angle is 75. Okay, let me say this as y. Okay, I'll say it as y. So in this triangle ABO, x plus y plus 75 is equal to 180 degrees, right? So that gives me x plus y is equal to 105 degrees. Okay, right. Now if I have to resolve this, find out the x, I should know the value of y. So I can't get any information from this triangle. So let me move to this other triangle and see whether I can get any information. Yeah, I have 95 degrees here, 40 degrees here, and this angle I can find out. Okay, I can find out, and if you observe, these two are vertically opposite angles, so this becomes y. Yes, this becomes y. So what is the triangle we are considering now? We are considering the triangle CDO. If you consider the triangle CDO, you know that 95 degrees plus 40 degrees plus, we know that that's y equal to 180 degrees, and you can simplify that and you will get y equal to 45 degrees, right? 135 plus y equal to 180, y equal to 180 minus 135, that's nothing but equal to 45. Now y equal to 45, substitute here, x plus 45 equal to 105, which gives me x equal to 60 degrees. Now you want to cross check that. Let's put the values and see whether it's satisfying or not. X equal to 60, y equal to 45, and this is 75. Add them up, 60, 105, 180 degrees, we are fine. Let's go to the other side. Y equal to 45, we have remaining two angles are 95 and 40. You add them up, 95 plus 40 is 135, 135 plus 45 is 180. So we are pretty good. I think we'll continue. I think we are running short of time. Yeah, pretty much. So in the next video, we'll be seeing some more interesting sums where we will club the parallel conditions, whatever we know, and also the intersecting line conditions, and try to do some interesting problems. Thanks for watching. Bye bye. See you in the next video.